Okay, so why use LangChain? LangChain just makes it easier to build applications that use LLMs, large language models. LangChain also allows you to connect your large language models to other sources of data, such as a database, a PDF, a CSV. You can make queries with LangChain much easier than you could if you used the large language model's own API, and it also makes it compatible across different large language models. You can also use JavaScript, but we're going to concentrate on Python, and there's a diagram showing where LangChain sits. So you've got your large language model that's got an API. You could query it straight from your code, but using LangChain makes it a lot easier, and we'll see that in due course. So we've got the features and also the use cases. You can create chatbots, you can answer questions using sources such as SQL, PDF, CSV, and so on. You can analyze structured data with LangChain. So let's get on with it. If a lot of this is new to you, a good place to go would be the OpenAI playground, where you can experiment, you can try different models, different modes. So let's just have a quick look at that. Okay, so I've given the system a message to tell it that it's a happier system. The first prompt will be, hello, how can I help? The user, the human, will say, what is a nice thing to say to a zookeeper? And then the AI will reply with, a nice thing to say to a zookeeper could be, thank you for taking care of all the animals. Temperature is set to 1, you can modify that. So it gets more creative if the further away you get from 0. You can also view the code. So what I've just written here, if we click view code, and it may default to JavaScript, so you can just select here Python, and let me just zoom out a fraction. That's the code that's generated. Now the code it's generated is to interact with the OpenAI API, not LangChain, but it's a good starting point, and you can see it's used chat completion.create, so it's creating the class instance with the model and some messages telling it what it is and some example message and responses. And yeah, that's the OpenAI API. So from now on, we'll be looking more at LangChain. But this is a good place to experiment, and this part is free at the moment. Okay, so if you want the best language model as of 2023, you will probably need to use ChatGPT 3.5 Turbo to use LangChain. So we're going to look at openai.com. You need to log in or sign up if you haven't already. You've got ChatGPT, DALL-E for images, and the API, which is what LangChain actually integrates with. So ChatGPT, this will actually take you to the web GUI where you can experiment and test out free of charge. So probably worth doing that to start with. And then once you've done that, you can then set up your API key. So when you set up your account, you'll need to add a payment method. I'm based in the UK, and I had to add my credit card details to allow me to get an account set up and then get my API keys. So API keys, they're all listed here. You can create a new one once you've registered, and you call it what you want. So video, create a new secret key. There we go, done. And that is what you will need to set in your environment variables or as a variable in your code, but I'd recommend not actually putting it in your code directly, as if you put it on GitHub or share it, obviously somebody else will get access to your key. So if you find your keys being leaked and somebody's got hold of it, you just click a delete and revoke it. Okay, I've structured the course in the same sequence. So we've got models, prompts, chains, memory, indexes, agents, and tools. As we go through, you'll see on the right-hand side, I've got the actual directories with the code inside. So you can get this from GitHub, and it will be in the same sequence. So I suggest you stick to that sequence, as it will obviously make more sense as you can follow along to the video. So I'm going to quickly show you how I create a new project, and then we will install LangChain with pip install LangChain and also pip install OpenAI. That will give us access to the OpenAI API, and then we will run our basic script, which will ask, why did the chicken cross the road? And we will get a suitably amusing answer. Okay, so if you've used the OpenAI Playground, you'll hopefully recognize some of these. You've got a system message and a human message. So these are called messages, and they get passed into the model. So basically, you're telling the chat model that it's a helpful assistant, and then you're saying that the human message will be whatever the user passes in, which is a variable called user input. The imports from LangChain.chat models import chat OpenAI, and also you need to use from LangChain.schema import system message, human message. When we run this, it will not be pretty, but it will be usable. And what color is grass? You see you've got content equals, so we'll go on to look at how you can pass that and get just the bit that you need, which is probably going to be the bit inside the quotes there. We're not interested in the additional underscore quirks or the content. Okay, so we've got our answer, but it's not in the format we want. We just want to actually extract the text part so we can use it somewhere else. So what we do here is we know that the key is content. So by using .content, that should just pull out the part we want. So what color is grass? And grass is typically green in color. So do you notice I asked it using color in English and it replied with color in American. Anyway, right, so that's actually just the way to extract the part that you want. And as we go along, you'll find that you have to do more and more parsing of your response, and we'll get onto output parsers and so on in due course. So if you're fairly new to this, you may think, why do you get chat models and why do you get just the plain old LLMs? So as of August 2023, GPT 3.5 is the default model for the OpenAI class. What's the difference between LLM and chat model in LangChain? So the LLMs, the models, take text string as input and return a text string. The chat models, so not the normal model, but not the LLM, but the chat model, they're backed by a language model, but take a list of chat messages as input and return a chat message. So that's what we just did. Chat models, unlike LLMs, chat models take chat messages as inputs and return them as outputs. I think the best way to understand it is to actually use it. As always, it's good to experiment with these. So instead of a helpful, you are an unhelpful system. Let's change temperature to 0.8 as well. The temperature, if it's 0, it makes it very logical in its responses. The more you get away from 0, the more creative it should become. Ask me a question. What is a good name for a donkey? Donkey McDonkey face. Okay. Let's just change this from unhelpful assistant to, I don't know, angry. Let's see what we get this time. What is a good name for a donkey? Because we've changed the temperature, it will probably give us a different answer in any case. I'm just curious to see whether it actually takes any notice of the fact that I've asked it to be angry. Okay, so it knows that it's apologising for being angry. Some good names for a donkey could be. So that's different to the previous one. The first time we asked it, it just said Donkey McDonkey face. However, this time it's given us 10 choices. So yeah, there we go. Let's change that to 1. Run it once more. Let's just see what we get. See if we get a list or if we get just a one-off response. What is a good name for a donkey? How about Stubbenstein? Okay. So there you go. You can see that you do get different answers each time. So it's not deterministic. Okay, so the examples we've seen just there were chat models. Let's look at what we would get if we were not using the chat model. So we're just going to use LangChain OpenAI class. Don't worry about the code. What we're just going to do is run a demo. And when it loads, it will prompt us, pick a country. So I'm going to say Austria. And what it should do is it will return very quickly the language of that country. So if we choose Brazil, country Brazil, spoken Portuguese. Now, this is not a chat model. This is just using the OpenAI class. So there's a difference. It's not a chat. It's not a conversation. We're asking it to do something, and then we are getting the response back. So prompts are the text that you send to the LLM. So if you use ChatGPT, you'll know when you type in a question, so that's the prompt. A prompt for a language model is a set of instructions, or it can be input provided by a user. It guides the model's response, helps it understand the context, and generate relevant and coherent language-based output, such as answering questions, completing sentences, or engaging in a conversation. So prompts can be a bit like a Python f-string. So you use a prompt template, and that allows you to dynamically pass in variables into your question. So you would use from LangChain import prompt template. We'll also look at chat prompt template. Okay, so system, that's a prompt. User, that's a prompt. And if we look at the ChatGPT GUI, we'll also see that the text that you put in here is also a prompt. 4.5 billion years. Just check we get the same result here. 4.5 billion years. So there we go. That's what a prompt is. It's the instructions that you pass in, and if you're using it in the GUI, it's basically just your question. But we will see how you can pass in a variable into that question to make it more dynamic. Okay, so again, doing it from the bare basics, from langchain.llms import OpenAI, we say the LLM equals OpenAI. Then this is the prompt, so how many minutes in a day? This is exactly what you would type in if you were using the GUI. So 3 lines of code. 1440 minutes in a day. Let's make it dynamic. What we need to do is create a template, and with that template we specify, if you're familiar with the Ginger syntax, the curly braces, that is the variable. So it allows us to ask similar questions. Prompt equals, so prompt is the name of our variable. Prompt template is the class that we import from LangChain. And if you hover over the prompt template, you can see what it's expecting. So it's expecting input variables and the template. So the template is the template, which we get from line 5. The input variables, and then we have a list of those. So I'm going to keep it simple to start with. So at the moment, we've got 1 input variable. So although that's a list there, you might think, why does it need to be a list? It's because we can have multiple variables going into our prompt. Here we're going to say on line 10, prompt, and we're formatting that prompt. So what that's doing is it's putting the word flowers, is transferring that into this part here. So can you tell me a riddle about, and then it's taking the word flowers and it's moving it into there. If you want to check your prompt, you can print it without using any tokens. So let's just run that. You can tell me a riddle about flowers with your answer. So yeah, that hasn't used any tokens yet because we've not invoked the OpenAI class and passed in our prompt. So next we need to define the LLM variable, which is our, you can call that anything, that's just what we call it. OpenAI class, and then how many minutes in the day. So if we run this, in fact we don't want that, we need to be passing in our prompt. So the prompt on line 18, that comes from line 10, which collects the topic, which is what the user will be passing in. So this time, we'll get a choice of what to actually ask the large language model about. If we change this, can you tell me a riddle about cats? Okay, this time instead of flowers, we're going to ask it to tell us a riddle about cats. What has 4 legs but can't walk? A chair. So that is not very good. Okay, let's see if we can do a bit better. So can you tell me a riddle about topic? And so the thing, and it matters, the order here matters. So we're going to pass in thing and then topic. So topic equals good. And then we'll say thing equals joke. So if we run this, it should ask us, can you tell me a joke about cats with your answer? What did the cat say when he lost his hat? Oh, forget it. Okay, so that was the joke. Okay, so we've now passed 2 variables. The next thing to do will be to collect these variables, joke and cats. Instead of those, we actually want to collect from the user. So here I just want to show the difference between if we use LangChain and if we don't use LangChain. So here you can see basically we've just got 6 lines of code. Ignore the imports there. Why did the chicken cross the road? So that is using LangChain, 6 lines. I know I'm exaggerating this a bit, but if we use OpenAI and call the API directly, we need to be passing in these messages, we need to be passing the response. I know I'm asking for a specific model there and specifying a temperature, so slight exaggeration, but you get the idea. When you're using the OpenAI API directly, a little bit more work. Again, if we didn't want to use LangChain, we could write our own code. And again, this is a class. So a class, 2 methods. We've got a chat method and then a pass method. So typically you'll pass in your message and then you'll need to format the response. So the code will be in the repo. If you want to look at how to write your own class using the OpenAI API, then this is an example for you. LangChain gives you various ways of specifying the prompts, and you do these via a template. So you create a template and then you pass the template into the prompt. Here you can see we've imported chat prompt template, system message prompt template, human message prompt template. Now, the first thing we're going to be doing is we're specifying the system template and then the system message prompt. So effectively, we're telling the model that it's a sports historian. It gives it some context. So system message prompt then takes the system template and tells the language model what it's actually an expert in. So system, human, and then we'll look at chat. So the human template, this is what the human being or the user is passing in. So 10 is just telling the model what it needs to be an expert at. 15 is use this template based on what the human passes in. Then the chat prompt is the chat prompt template from the messages. So what it's saying is use the system message prompt, the human message prompt, so use all of the prompts that we've already created. So based on all of those prompts, we've restrained or we've guided the language model. So then the chat prompt equals, and then we format the question. So when we format the question, we're using format underscore prompt, and basically that is going to put F1 as the sport, which is going to tell the AI model that it's a Formula One historian. And then the text is what then goes. So these two things here, the sport and the text, sport goes to the system template and the text goes to the human template. And then when we call them all together down here, we're saying from LangChain chat models, and then we're passing the chat prompt, which is what we've already discussed here. So if we run this, it should tell us who won the Grand Prix in 2015. And I've not formatted that, so the response is a Python dictionary. So we've got the key is content, and then the value is this text, and additional keyword arguments, none. And obviously we can then pass that out by doing res.content and so on, like we saw in the earlier video. If you're liking this video so far, please subscribe or give it a thumbs up or leave a comment. Okay, next. We just looked at a single shot prompt template. So the other one you can get is a few shot prompt template. And what happens is you set some, basically you pass it some examples, multiple, so that's why it's few rather than single. So line 6, which is quite in the language model, as OpenAI is as same as always. And as always, it doesn't have to be OpenAI. You can specify whichever language model you desire. This is the different bit here. So we've got examples. So we're passing in some examples of questions and answers, basically, to kind of guide it as to what to do. Create an example template. The example template will be the user has the query, the user passes in the query, and then AI provides the answer. So create a prompt example from the above template. So we're using prompt template again. So prompt template from, we imported that on line 4. Input variables, query and answer. Those are the variables. Template is example template, which is what we've just specified here. We're specifying that there will be a query from the user and the AI provides the answer. Next, so we're going to pass in a prefix and a suffix. So the prefix is some guidelines. So the following excerpts from conversations with an AI assistant. The assistant is typically sarcastic and witty, producing creative and funny responses to the user's questions. Here are some examples. So next we then say examples, and then the suffix is the input and the output. Few shot prompt template. So we're using the few shot prompt template class, and we're telling it to use the example prompt, the examples, the prefix and the suffix. The prefix and the suffix bit take a bit of getting your head around. So copy this, modify it, break it, as always. So I'm going to pass in my query. So this is where I'm actually calling. So the query will then be passed in, and I'm just going to just print the output of the LLM, which is going to use the few shot prompt template, and I'm just going to format it. So the formatting bit is just basically saying that the query is my query, which is what I've just said on line 54. So if I run it, again, a lot of this is so new. This one is actually, I find, a little bit complicated with the prefix and the suffix. But yeah, there you go. Life is what you make of it. So it's produced that answer after being trained on these two examples. So that was, what time is it? It's time to get a watch. That's slightly sarcastic. How are you? I can't complain, but sometimes I still do. I wouldn't say that's sarcastic, really, but just remember that the prefix, the following is the example conversations, that you're telling it to look at the example conversations. And then the suffix is basically use this query and then give us an answer. Okay, chains. So we're moving on now, and chains are a way to pass the answer from your first question into a second question. I think that's as simple as it can be explained. I'm going to run this, which is a Strreamlit example. If you've not used Strreamlit before, basically it's just a Python way of making a web GUI. And I'm entering a prompt, fix a bicycle. Even though I've spelled it wrong, it should still find the answer. Are you completely new to biking and don't know where to start? So what it's done is it's actually created me a script. Now the script is based on the title, and if we look at the code, what actually happened there was it created a video title based off my my incorrect spelling of bicycle. So it created the title, and then from the title, it then passed that title, which it generated, passed it in as a variable, how to fix a bike, an easy guide for beginners. And that was then what it created the description on. So let's look at the code. First off, with Strreamlit, let's comment this out. So import Strreamlit as st, you'll need to do pip install Strreamlit. We create a title, that's just a label. A text input, so that's basically an input box. Enter your prompt here. Whatever goes in that input box becomes the prompt. Now we've got prompt templates. We've got two templates, the title template and the script template. The title gets created from our first prompt, and then the script gets created from the output of the title prompt. So it's a two-step process. If we scroll down, you'll see we've got two chains. We've got a title chain and a script chain. And then what you do, so that's like a link of a chain, and then down there on line 32, we join those two chains together. And they need to be in sequence, the correct sequence. So the first thing we do is we create the title. So the title will get generated based on the topic, which is the name we assign to the input variable. Once we've got the title, that's part one of the chain. That's the first link in the chain. Next, we create the script chain. The script chain then takes the output of the title chain. We call sequential underscore chain dot run, and then we pass in the prompt. So the prompt we pass in, so all we're passing in here is the initial prompt. So we're just passing in how to fix a bicycle. So we pass in how to repair a bicycle, goes in here, and then that generates the title. And then based on the title, the second call then generates the description based on the title, which is based on what we've passed in our input box. That's me explaining it very quickly. The best way to understand it is to download this code and edit it and see what happens. Simple sequential chain produces only one output. So it's basically one link of a chain. That's all the chain is. The sequential chain, the output of the first chain goes into the next chain, and you use from LangChain.chains import and then either simple sequential chain or sequential chain. Memory. So by default, large language models are stateless, which means each incoming query is processed independently of other interactions without memory. So every query is treated as an entirely independent input without considering the previous interactions. There are quite a few options with different trade-offs for memory. We've got chat message history, conversation buffer memory. Conversation buffer memory, it uses lots of tokens and it's slower, but it stores everything. We've also, so that keeps a sliding window of the most recent interactions, so the buffer never gets too large. We've also got conversation summary memory, which keeps a summarized form of the conversation. It progressively summarizes the lines of the conversation provided and adds them onto the previous summary, returning a new summary. We've also got conversation entity memory, which if you've used Spacey or NLTK before, you'll know that entities are categories of the type of word, so verb, a noun, adjective, and so on. Here are some more memory options. So you've got buffer summary, buffer window memory, and also conversation KG memory, which I think is quite new and it's got a lot of potential, but you won't find many tutorials using KG memory yet. If you want to see what's actually stored in the memory, you can do, for instance here, you can do conversation.memory.entity_store.store. Okay, so I've modified the code slightly and I've added in output key equals title and output key equals script to the chains. And also we have to specify with the sequential chain, the topic is the input variable and the output variables being title and script. So when I run this, it should actually print both the title and the script to the screen once it loads. So it's going off and getting the description, a good video title rather, and then it's creating the description based on the title that I've asked it to create. There we go. And what went on behind the scenes is write me a YouTube video description based on this title, and it knows that the title was How to Make a Beer at Home Step-by-Step Guide, and that title is based upon my user input. Okay, so we might want to keep what we've asked it, and obviously with a chatbot you want to keep the conversation memory. Here I'm going to use the conversation buffer memory. There are other types, but for now let's just try that. Don't worry about the complete code, let's just run it and then we'll come back and look at it. Okay, so to begin with, we've got no real history or no real chat history. So to demonstrate that, let's copy that and paste that in here, and then what is the tallest tree? And we also need to print, because otherwise we won't know what we're appending to. If we run that, the first print statement will be identical to before because it's just got the input, the history is empty, and then the response is good morning, how can I assist you today? So the input was me, the history was empty, and the response was good morning, how can I assist? Then the input was me, what is the tallest tree? The history was good morning AI, and then so that was me saying good morning AI, and then good morning, how can I assist you today? So we have the history of what I asked, and then we have the history of what the AI responded with. And finally, we've got the response to my second question, which was, what is the tallest tree? So gradually the chat history is being appended to with the conversation buffer memory. Indexes refer to ways to structure documents so that LLMs can best interact with them. This module contains utility functions for working with documents, different types of indexes, and then examples for using those indexes in chains. The most common way that indexes are used in chains is in a retrieval step. This step refers to taking a user's query, returning the most relevant documents. So it's a similarity search. We draw this distinction because an index can be used for other things besides retrieval, and retrieval can use other logic besides an index to find relevant documents. We therefore have a concept of retriever interface. This is the interface that most chains work with. Most of the time when we talk about indexes and retrieval, we are talking about indexing and retrieving unstructured data like text documents. For interacting with structured data, SQL tables, etc., or APIs, please see the corresponding use case sections for the links to relevant functionality. The primary index and retrieval types supported by LangChain are currently centered around vector databases, and therefore a lot of the functionality we dive on those topics. So we're going to look at document loaders, text splitters, vector stores, retrievers, and go deeper. Okay, so this is what we're going to do. We're going to get some free books from Gutenberg.org. They are books which have no copyright on them anymore because they are so old. We're going to use Python. The code will upsert, so upload and insert these books. What it will do is it will break each book or each page even up into chunks which can then be insertable into the vector database, such that when we write our code, we can retrieve based on the similarity between our question and the content of the database. So if we ask a question about why is Alice in Wonderland running after a rabbit, it will find the most similar sentence or paragraph, or basically we split up into chunks of 1,000 characters. There is a free way of doing this as well, which would be to use Qdrant's own client with the similarity search feature. That would return you a paragraph, whereas if we use a large language model with LangChain, we can actually ask questions rather than just retrieve a paragraph. So that's what we're going to be doing. We're going to be using Qdrant, Python, large language model, OpenAI, and LangChain. You don't have to use OpenAI, but we will here. So what you'll be seeing here is me typing in all of the code which is required to insert the text into the database. We split it up into chunks, we put the chunks into batches, and then we upsert the batches, and then we will be able to query it. So I'll let you watch the rest of this. The code is also on my redandgreen.co.uk website if you would like to copy it. If you want to see this code actually working, you can see the retrieval code at around 46 minutes. This is me typing in the recreate collection. So just remember, recreate collection will actually delete any existing collection with the same name. Now I'm doing the make chunks, and I'm using the recursive character text splitter. So we're splitting up the Alice in Wonderland text, and every 1,000 characters we are effectively slicing it. I put in a chunk overlap of 20. If you don't have a chunk overlap, you could end up with the 1,000th character could be halfway through a word, which might be halfway through a sentence. So if you've got slightly too much of your first one and slightly too much of your second one, then you get some overlap. So that increases the chances of one of the chunks actually making sense. Well, in fact, it really should make sense. So the make chunks is returning the chunks, and then I actually call that on the text. The reason we make the chunks is so that we can do the upsert in batches. Otherwise you'd be making so many network calls, or if you were using the cloud, or you'd be making so many calls to Qdrant, it would be slow, or slower. So I created this gen vectors function. So what we end up having is some generators which we iterate through when we do the upsert. So the whole purpose of this code is to create a final NumPy array which we can iterate over, which will contain all of the vectors. So I used 384. When you specify the dimension, such as 384 or 768, you need to check what the embedding or the sentence transformer model you're using is going to output. So 384 for this particular one, but that may change depending on which model you use. I typically, for experimenting and learning, I use a smaller model because it's not critical what model I use, as long as it's small enough to download locally to my computer, to my laptop. As I say, the retrieval code is coming up shortly, so in a moment I'm creating fin vectors and fin payload from this tuple. The gen vectors creates me a tuple, so the fin vectors, fin payload, they are the generators which I can then pass into the, it's not called I don't think it's called, yeah, to the point struct. So inside the point struct I then iterate over my generators. Some of my terminology may not be 100%, but so much of this is new to me, and I'm sure it is to most of you. So I can guarantee you that this works, however. So I'd rather have code works that's badly explained than code that's wonderfully explained but is useless. I was told that you could leave out the ID and it would be self-generated, but I've actually based the ID, I've used enumerate to take the existing highest ID number and then keep adding to that. Basically because with the Qdrant documentation, much of it is based on only ever doing one batch of upserts. And if you've seen my website, findthatbit.info, over a period of time I'm going to be needing to add more video transcripts to it. So I need to be able to upsert, basically append to my collection. So to append to my collection, I check what the current highest ID is and then obviously add to it. So really, with these upserts, there's three things, and if you've seen Pinecone, similar idea. So you have your vectors, you have an ID, and you have your payload. So the payload is basically the human readable, the text version. The vectors are the vector equivalents, and the IDs are the IDs. Pretty similar to what you would have in a relational database. So then you need to start Qdrant. You can either register for a free version in the cloud, much like you would do with Pinecone, or you can download a Docker image, which I always prefer to do because it's free and it's easy for me to control and interrogate and know what's going on locally. It's written in Rust and it's really fast and robust, which is good. I've yet to crash it or freeze it or anything. So you sudo docker pull Qdrant and then you start it up with the usual Docker commands, sudo docker run -p for port, and then 633. And once it's running, as you can see now we are ready to actually run the code that we've just written, which will do the upsert to Qdrant. The text, you didn't see me do it, but I went to gutenberg.org, searched for Alice in Wonderland. I clicked on get raw text. And I just did a Control A and did select all and copy Control C. And then I just pasted it into an empty .txt file that I'd created in VS Code. The one thing that I have noticed is you do have to pass the absolute path. That's something I'm going to double check in future, but for now I'm happy to use the absolute path when I specify the path to the text file. And you can see in Qdrant there's something happening, which actually was the upserts taking place. You can see there were some 200. I think that was yep, that was when I was doing the upsert. So here I am checking it, and you can see I've got one collection called AIW, which stands for Alice in Wonderland, and the point. So each point is like a row in the database. So you can see the payload. You can't see the vectors because obviously the vectors wouldn't really make any sense to a human. And yeah, each point is a row in the database, or equivalent to a row in a relational database table. And then what we've got here is some code which you can run. So the hyperlink to this you will be able to find when you fire up your Docker image. It will show you in the terminal. And here we are, we're just running some very basic code which gets collections. So if we had many collections, we could see each collection name. And there you see vector count, 170 vectors which have been added by the code. So now that means we are able to query it. Okay, so I'll quickly cover what I did here. This is writing the retriever. So we're importing Qdrant again. We're using Hugging Face embeddings, doing all the imports. So we're using retrieval QA, and that's the bit that gives us the retriever. That's the class that provides a retriever, which allows us to search the vectors and effectively do the similarity search based upon the data which we just upserted into the Qdrant vector database. This code's much simpler, it's much shorter because we don't have to do all the chunking and the embedding, it's already in the database. So really what we're doing here is we're doing the query. So we're basically establishing a connection, we're specifying how we want to encode our question. It needs to match the way that we encoded our data. I've spelt retriever wrong there, but I'll come back and fix that. So that's the question. Obviously the question could be input dynamically through an input box or a user prompt, and then that's running it. There's a little bit of delay, it takes a second or two, and then we get the answer. So it's queried the database, and you can see there that's the output from Qdrant, and you can see the post request to the collection was successful, and we got ourselves a valid answer. If anybody's read Alice in Wonderland, you probably know that she drank from a bottle that said "drink me." Now, what if you want to debug your code? So I've added import LangChain on line 6 and LangChain.debug equals true on line 7. And if you run Python with the -i flag, which I'm about to type here, you can get the debug output, and it takes you into an interactive prompt. So it will run the code and it won't exit, it will leave you so that you can query your variables basically, or your functions. You can query what is in your code. So there you see that would have been the paragraph that would have been used to find the correct answer. And you can see the chain. You've got the retrieval QA, you've got the stuffed documents chain, and you've got the chain LLM. You can see the prompt tokens. So it used about 1,000 tokens, which I don't know if it still is, but it was about 3 cents. So run this 100 times and it's cost you $3. So that was using import LangChain and then LangChain.debug equals true and specifying the -i when we called the file. So it's Python -i file name. Okay, so if you follow the link from the terminal that you get when you start Qdrant using Docker, click on Visualize on your collection, your specific collection, and if you run what I've just clicked there, you get a 3D, it is 3D as it loads, rendering of the vectors, and you can see which vectors are closer together, so more similar. So with a similarity search, it is all about which vectors are closest to the vector of your question. And if you hover over, you can actually see the payload that corresponds to the vector. Probably not something you'd use all the time, but from a learning or educational point of view, it's quite interesting. And it kind of gives you a visual idea of what's going on under the bonnet with the code. And you can see these two are quite close together because I think it's because they both say puppy. So they've got similar semantic meaning. So there we go. That's a nice feature of Qdrant, and it's free. This is the standalone version. I don't know if it's, presumably it's also available with the cloud version. I've not tried it. I think you get one free collection with the cloud version, so probably worth trying in due course. Okay, agents and tools work together. So the core idea of agents is to use a large language model to choose a sequence of actions to take. Chains, a sequence of actions is hard-coded. Agents, a language model, is used as a reasoning engine to determine which actions to take and in which order. There are several key components here. This is a class responsible for deciding which step to take next. So you've got agents and you've got tools. Tools are the functions that the agent calls. There's also router chains, but I'm not going to cover that here. That's subject of another video. But the tool, so what you need to do is give the agent access to the tool, and then you need to describe the tool in a way that is most helpful to the agent. Just to get started, let's look at some code that uses an agent with one tool. We know that large language models are terrible at maths, so that's what we're going to use here. We're going to use a math tool, which will be selected by the agent to solve a problem. What we've got is from LangChain agents import tool, from LangChain import math chain, and then initialize the agent. So we've got a tool, a chain, and an agent. And then, as always, we choose a large language model. And again, we've chosen OpenAI. First thing we do is we specify the chain. So using the LLM math chain class, we create an instance of it, and we tell it to use large language model, and we tell it to set verbose equal to true. So we've got a chain, then we create tool. So the tool is an instance of the tool class, and we'll call it calculator. And this is the important bit, useful for when you need to answer questions about math. This tool is only for math questions and nothing else, only input math expressions. So we've got a chain, we've got a tool. Next, we need to actually make a list of our tools that we can then pass to the agent. So what I've done here actually is make an empty list of tools, or an empty list even, and then we're going to append the tool. This is useful because in future code you may actually decide that you need to add an additional tool based on some condition, and then knowing how to append the tool, knowing that the tools is a list and knowing that you can append to it is quite useful. So we've got our tools, we've got a chain. This is the agent, zero shot agent. This is probably the most common one or the first one that you'll come across. And it's zero shot, reason, act, and then description. So it's gonna do its reasoning and take action based on the description. And the description was this on line 12. So we say verbose equals true, max iterations equals 3. You don't have to set verbose equal to true. You don't have to set max iterations. Setting max iterations actually stops it getting into a loop and using up lots of tokens. So probably a good idea, especially if it's your money or if you care about the charges. Query 1. So we'll make our first query. And I know from experience that if you try and calculate the cube root of 625 using OpenAI, you get a very bad answer, which actually, let's just show you that. Okay, so what is the cube root of So 5 times 5 is 25. 5 times 25 is 125. So wrong, incorrect, bad. Let's give it a thumbs down. There we go. Submit some feedback. Right, back to our code. So you can see the reason why we need to use the math tool rather than just rely on the large language model. So our result is going to be the zero shot agent. So the agent.run, this is what you use to run a tool. So print result, and let's go for it. And as ever, it's reading my API key from my .zshrc file. And that is the correct answer, 8.54. Good. So this is the benefit of using a tool, especially if you want the large language model to do some maths. So this is the first example. Let's look at something else which uses more than one tool. Okay, so this is where it starts to get a bit more fun. We've got LangChain agents. We're adding some memory for the conversation buffer memory. We're also using the SERP API wrapper, which I believe with the free version via Google, you have to do pip install google-search-results and then register for the free version. I think you get 1,000 requests a month, something like that. So you probably wouldn't want to be using it in production with the free version, if indeed that's allowed. But for the sake of learning, it's fine. Memory equals conversation buffer memory. If you remember the buffer, you'll obviously rotate and remove the very oldest entries once it gets full up. Not that it's going to. The large language model, OpenAI, again, you could use whichever model you desire. If you want to run a model locally, you could. Here, just note that even in the current LangChain documentation as of August 2023, you may well see LLM math chain, LLM equals LLM. Don't use that anymore. You can't instantiate the class directly. You need to do from underscore LLM. You see the difference? So before, on line 16, that was before. And now you need to do from underscore LLM. That'll get rid of any annoying deprecation warnings. So that's one tool. So the agent is going to select the correct tool that it needs for job or its current task. That'll be based upon the description that we give it. So here, we're going to create a list of tools. So we're going to put in 2 tools. So the format is tool, capital T. So make sure you've got tools with a capital T, and also you will see tools with a lowercase t. Name equals current search, name equals calculator. You also pass so within the tool, you've got a name, you've got a function. So that's what actually happens when you call it. And then you've got the description. description is quite important because that is what the agent will use to make a decision about which tool to use. So you've got an agent and you've got some tools. And then down here, we're just saying again, we're actually loading the tools. So we've just made a list of the tools here. Now we're actually loading the tools. So we're telling the LLM, here are your tools. We initialize the agent. So we say, agent, use these tools, which are now loaded because we loaded them on line 34. Here we're going to use zero-shot React description. We're going to use description here means it's going to pick the correct tool based upon what we've put on line 24 and what we've put on line 29. So just to show that we are actually doing something which involves data more recent than when the OpenAI chat model was created, I've asked it what was the average age of the UK Prime Minister between 2019 and 2023. If you know anything about UK politics, which is an absolute horror show, but I better not go there because I'll get banned if saying what I think. The UK Prime Minister has changed once, twice, three. I think we've had three in the past 3 years. So what it should do is go and look up the age of each Prime Minister over the past 4 years, add it together, and then obviously divide by the number. So let's run it. And to run it, I just need to put up a new terminal. So I just need to source my virtual environment, entering new executed chain. I need to find out the ages of the Prime Ministers during the time period. So it knows the current one, and now it's gone off and looked up the others. So we've had a 47, a 68, a 55, a 57, and a 52. Wow. So the average age of the UK Prime Minister between 2019 and 2023 was 55.8, based upon a 47-year-old, a 68-year-old, a 55-year-old, a 57-year-old. There we go. So that was using tools to answer a question where we needed to look up some data and then we needed to do a mathematical calculation. There's a lot more to tools than this. You can create your own tools, which is a really cool thing to do. There's also other different types of agent as well. So lots more, which I can't really cover here because by the time I've covered it, some of it probably will have changed again. So yeah.